Hi, my name is Vaughn Hughes and my project is on using environmental enhancements to increase vitamin C production in Spinacia, oleracea, or spinach in varied agricultural environments. The Earth has a problem. By 2050, the world's population is projected to grow to over 10 billion people, and while the need for food is increasing, the soil quality and amount of arable farmland is decreasing. According to NASA, the Earth has lost over 1/3 of its arable farmland in the last 40 years. To help fill this gap, the agricultural industry is going through a revolution in the form of vertical or urban farming. Vertical farming grows crops indoors without sunlight or soil in places like abandoned warehouses and shipping containers near big cities in order to provide fresh produce to consumers. It also produces more than 130 times as much produce as a conventional farm its same size. Sounds great, right? However, its produce has been shown to have less vitamin C than conventionally farmed produce. This could pose a major problem if vertical farming becomes a main source of produce because iron deficiency anemia, which is caused by a lack of vitamin C in the diet, is the most prevalent form of malnutrition worldwide. I researched and found that the top 20 vitamin C producing crops have one thing in common: harsh growing conditions. Could vertical farmed produce have less vitamin C because abiotic stress is removed from its environment? I hypothesized that the addition of abiotic stress to the vertical environment would stimulate the ascorbate glutathione enzymatic pathway, increasing vitamin C production. Stress, in the form of wind, heat, and drought, was applied to Spinacia oleracea in a vertical farm environment, and vitamin C was measured by titration. This table shows the box plots of my results from phase 1 of my experiment. The vertical axis shows the level of vitamin C in each plant sample. This phase of my experiment sought to establish a baseline difference in levels of vitamin C between the vertical farm environment compared to those plants grown outdoors. The results for 3 vertical farm methods are on the left. As you can clearly see, each of the vertical farm groups had statistically significantly lower levels of vitamin C than those of the outdoor group with a p-value of less than 0.01. Phase 2 of my experiment was the stress round and used the AeroSun group as the basis for comparison. The results show that the mean vitamin C levels of the treatment groups were all statistically significantly higher than that in the AeroSun group. Phase 3 was the interaction round. Heat stress combined with wind stress were chosen for the interaction. The results show that the vitamin C levels of the interaction groups were further enhanced and were statistically significantly higher than those in the heat group with a p-value of less than 0.01. While the vitamin C levels of the interaction group were higher than those of the individual treatment groups, they were not statistically different from those of the outdoor group. I found that adding abiotic stress to the vertical farm environment could increase vitamin C output, and with the addition of wind and heat stress together, vitamin C levels can be equal to that of conventionally farmed produce. This will be important as a significant shift in the way food is produced could have a profound impact on human health, so it should be done so with nutrition in mind. Thank you.